All right, here's my first attempt at a YouTube video lesson. So we'll see how it works with my smartboard. We're going to go over rational exponents. Now I have a 10-minute maximum for each little video, so I have a timer set. And I'll see how far I can get in 10 minutes. If I go beyond it, I will have another part to this in another video. All right, the very first parts of this lesson is quite simple. We've already talked about this in length. So we're going to write each expression in radical form. Now as it is, they are written in fractional exponents. And we are familiar with the idea then that 1/6 power is the same as a 6th root. So this is writing it in radical form. M to the 1/2 we're quite familiar with. That is square root. And that would be the answer for B. Going the other direction is as straightforward. 1/5 root is B to the 1/5 power. And you don't really have to use parentheses. That's good enough. Square root 1/2 power. This is something we've done before, so this is not new. The rules are pretty much the same when it comes to fractional exponents as they are with regular integers or for exponents. If we have a negative to the power, and that's the same as any other question with a negative exponent, we would put it below and in the denominator. So this question is really asking us it's 1 over the square root of 49, and that is equal to 1 over 7. Now what we're going to do is we're going to start to think about different ways of representing our base numbers. We did this a little bit last lesson. I mentioned it a couple times, but it's going to do us it's going to have good payoff if we take care of some things at the very beginning. Now 32 can be rewritten as 2 to the 5th power. You can check that on your calculators. And we're going to raise that to the 2/5 power. It is in this form that we're going to be most efficient. So if we take 5 times 2/5, we'll get 2 to the 2nd, which is 4. Okay, so a very important part here. We took 32 and rewrote it as 2 to the 5th. Whenever possible, that's something we want to do. Now, when we have bases being multiplied, same rules apply. We add exponents. It just so happens that the exponents are fractions, so you have to go by the rules of adding fractions. Do they have a common denominator? And if they do, we just add the numerators. So the answer for this one, the best we can get, is y to the 5/7. The next one, if you follow the same rule as our last question, we have a negative exponent. So we have x to the positive 2/3. This means that there's a root in the denominator. So let's think back now. How do we rationalize the denominator? I'm going to multiply top and bottom by x to some power. So the question is, x to what power plus 2/3? So the power of the x plus 2/3 gives you 1. And that would be 1/3. So 1/3 and 2/3 gives you 1. So that will give you x to the 1 in the denominator, x to the 1/3 on top, which means cube root x over x. Now there are some questions in your notes that I don't have here, so I'm going to do them, handwrite them here if I can. We have x to the 1/5 times x to 7/2. I think you have this in your guided notes. They are like bases, so we can add exponents. That'll give you 8 to the 5th because they have a common denominator. Now how do we simplify that? Now here's where I'm going to get back to the notes where I had 5 steps for you with fractional exponents. I'm going to rewrite 8/5 as a mixed fraction, which is 1 3/5. Then I'm going to separate that as x to the 1, x to the 3/5. So what this tells us is that we will have x and then a cube root, oh, excuse me, not a cube root, but a 5th root of x cubed. That's how we would approach that problem. And I think this was C in your guided notes. D is y to the negative 3/4. Same rule applies. That must go in the denominator. Now, y to 3/4 times y to what power will give you 1 for a power? That is 1/4. So this will give us y in the denominator, and above we will have y to the 1/4, which simplifies down to, or just is rewritten as the 4th root of y over y. Okay, next question. Now we're going to get into some interesting things. Those are just dealing with the properties. Now, as I said before, when it's possible, rewrite a number as a smaller number to a power. So let's take a look at 16. 16 is the same as 2 to the 4th. So I'm going to take 2 to the 4th to the 1/6 power over 2 to the 1/3 power. Here, we will take 4 times 1/6, and that will be 4 over 6, and that reduces to 2/3. Now, this is a situation where we have a root in the denominator, and we would want to rationalize, except we actually can do something here since we have base of 2 in the numerator and base of 2 in the denominator. And the rules of exponents says that we can take the power of the top one and subtract the power of the bottom one, which gives us 2 to the 1/3, which will give us 3rd root 2. I'm going to stop here so I can stay within my 10-minute limit, and then I'll start a second piece for the end of this lesson.